So let's talk about data types. So let's create a new file. First thing you'd want to do is include IO stream and open your main. Int main. To verify everything is working, just hit Command R and yep, everything's working. Okay, so data types. The most used data types are int. So int my age is 26. So I've just declared a variable called my age, which is an integer, and it holds the value at this line 26. I could have done this, so initialize a variable without having it holding any value, and then my age is equal to 26. Both are the same. You cannot say my int is 26.3. If you run it, it will give you a warning. It's not an error, it's a warning. And why is it so? Because int does not support decimal representations. It's only the integer part. So it's a 26, not a 26.3. You've also got float, which is a floating point. Let's say pi is 3.14 almost. It's accurate up to 10 decimal representations. You've also got double. Double is also a floating point. Let's say e. Double E is 2.71. It's accurate up to 15 decimal places. You've got the bool, which is a boolean, is rich is equal to true. So I've set the variable is rich to true. I've also declared it as a bool. You can also call it char C, which is A. Let me give it more meaning. Grade. Grade is A. And if you want to print any of those out, all you have to do is C out. Let's say the value of pi is, if I do so, and L means end line, and run. So we have to use using namespace std right here. And if we run it right now, we can see the output printing the value of pi is and end of line. So that if I want to print again, I start with a new line. So let's say I want to print the value of pi. All I have to do is insert those less than sign twice, and then pi, which is the value right here, run, and there you have it. The value of pi is 3.14. You could do the same thing for other variables. Let's say you want to print e. Value of e is 2.71. Value of is rich is what? Is rich is 1. True is 1, and false will be, in case we're printing them, is a 0. Let's copy paste this one. The value of grade is grade. Run. The value of grade is A. And we forgot my age. Let me put it on top here. The value of my age is my age, right? Exactly, it's 26. So let me just change the grade here to B. Run. We'd no longer get A, we'd get B, right? Because I've changed it right before calling grade right here. So other types of variables are here. You've got the short int, which is up to or at least 16 bits. Long int, which is at least 32 bits. And you've got the long int, which is at least 64 bits. So the way you declare it is long int, a very long int, and you can store up to 64 bits. And let's print out my long int is, it should be printed at the end of everything. Okay, so let's do some arithmetic operations. Let's say I want to add two integers, a, which is 2, and int b is 3. Output it like so. The result of a plus b is equal to a plus b. This is one way of doing so. So run. So a plus b is 5. And result, not result. So the result of a plus b is 5. Another way of doing so is declaring another variable and see out the result of a plus b is equal to c, right? So you can do the same thing for subtraction. So indeed, a plus b is 5, a minus b is minus 1, a times b is 6. But a divided by b is not 0. So what's going on? The thing is that since a is an integer and b is an integer, then any operation having to do with a and b is also an integer. So a divided by b is an integer. So 2 divided by 3 is 0.666, something like that. And therefore the integer part of 0.66 is 0. So to avoid this, all you have to do is insert a float here. So you need the result to be a float. This is called casting. So running it right now, the answer, the correct answer, which is 0.6666. Another way of doing so is declaring a float which is D, it's A over B, and print the result of A over B is D. Go. So you always have to cast the result. Other stuff you can do, let me comment all this out. Let's say you have int A is 4 and you'd like to print out A++. A++ is the equivalent of adding 1 to A after executing this line of code. So now if I go ahead and type in value of A, it's not 4, it's 5. On the other hand, if you want to increment the value of A on the same line, you have to insert the plus plus before A. So now A is also 6. Right? You can do the same thing for minus. It means that you're not going to decrement it at this line of code. No, it's going to be decremented after. So A is now equal to 5, right? As you can see here. So one last thing is minus minus A is 4 indeed, for the same reason as plus A plus plus A. Oh, sorry, I didn't execute it here. Now we print A to show that it is indeed 4. And I forgot a semicolon, so run. Let's do some conditionals. Let's go here and create a new script called conditionals.cpp. So conditionals are a type of way to execute some code when a certain condition is satisfied and execute another block of code if it is not satisfied. So what I mean is this. Let's say my bool is in first block equal true. If is in first block, execute. So this is some comment right here. Execute first block, else execute second block. And here I'll just print I am in first block and see out in the second block I am in the second block. So if I run that, since is in first block is true, then this block of code will execute. Otherwise, this block of code will execute. So run that. I am in first block. Now if I set it to false, I am in the second block. Okay, comment that out. Let me show you another way you can play around with conditionals. Int my age is 26. If my age is double equal, so double equal, now this is a statement. It's either true or false. So when I have double equal, this is a statement and not an assignment. This is an assignment. Assignment as in putting the value of 26 in my age. This is a totally different thing. Right here, all I'm doing is checking. Is my age equal to 26? So it's either a true or a false. Now, if it's true, I'll throw out the following message. You are 26. Don't forget the semicolon. Else, see out, you are not 26. End L. So run, you are 26. Now let me put something other than that. 25. You are not 26. Put 27. So you can also do other type of stuff. You could put nested conditionals. Like, let me remove this. So if I'm 26, print that you are 26. Now if my age is greater than 26, see out, you are greater than 26. And L. Else, see out. So if you're 26, it's going to print you are 26. Now if you're not 26, you enter this block of code. If you're larger than 26, the following will be executed. Else, we did not specify the condition, but you will only enter this block of code when you're strictly less than 26. So let's see what's going on. You are greater than 26. You're actually 27. Let me put 25. I should be right here. So you are less than 26. Let me put it exactly 26. You are 26. So you could also play around with else. So float pi is 3.14. If pi is 1, see out, something is wrong with my math, right? Because pi is not 1. Else if pi is 2, something is not correct, right? Else if pi is 3.14, I'm fine with my math. So let's give it a shot. Okay, so let me cast this thing right here to a float. Okay, so you've got to know something. If I put a double here and I do not put a double here, it will take it. But if I put a float here and run, it will not take it. So automatically, if you declare decimals, the compiler will understand that this is a double and not a float. So in order to tell it that this number is not a double, it's a float, then you have to cast it as a float. So indeed, pi is 3.14. Let's go with a double and remove the casting. I just wanted to show you casting in conditionals. So I'm fine with my math. Let me put 3. You will not get any message. nothing, because it's not 1, it's not 2, it's not 3.14, so none of those would execute. There's another way of typing or using this type of flow. It's the switch command. So switch pi, case, let's say pi is 1, cout pi is 1, and you have to insert a break so that it stops executing the switch statement, so that it exits the switch block. Case 2, cout pi is 2, break, and case 3.14, cout, all is good. Let me remove everything here. And you've got to put a default statement. Default. So the default statement executes when none of the cases are satisfied. So we'll print it's not 1, nor 2, nor 3.14. So run. Pi is not defined. Let me copy paste it here. Pi is 3. So we've got to change this double to an int. Switch only works with integers, so 1, 2, and 3, not 3.14. And is neither 1 nor 2 nor 3. All is good except that we have to add 0.14. So run 2, pi is 2, pi is 1, and let's put 4. Pi is not 1 nor 2 nor 3. Let's put 3.999, then it's a warning. So what the compiler does is that it takes the integer part, which is 3, and executes this block of code. So all is good except that we have to add 0.14. You can also add statements such as if true or false as follows. Now this does not make sense, but bear with me a bit. I am always going to be here. I will never be here. So what's going on here is that this is an OR operation. So here we have some logic going on. Let me show you what I mean. So I'm going to get two binary values, A and B. So A could either be 0 or 1, and B could either be 0 or 1. So we're going to talk about OR and not. Okay, so I'm going to draw a table here. This is A and this is B. This is A or B. This is A and B and not A. I'll denote it by an exclamation mark because this is how it's written in C++. OR is denoted as follows. So A or B, and is denoted as A and B. So 0 is a false and 1 is a true. All the possibilities you might face when you're performing operations on two booleans is the following. You have 4 cases. In the case where they're both false is false. Else, they're all true. A and B, they're all false, except when they're both true. And not A is just negating what you have. So if it's false, then it will evaluate to true, and then the true will become false. Okay? So it's really important to keep that table in mind. Let's say I have the following. So since I'm born on the 3rd of October in the year 1991, the compiler goes here. My birthday is 3, my birth month is 10, my birth year is 1991. So all 3 are satisfied and we're using an AND. So keep in mind that AND requires all the statements right here to be satisfied. No matter how many statements you have, a way to memorize it, a way to keep it in mind is that all statements should be satisfied. If one is not satisfied, then this block of code will not be executed. It means that this statement will evaluate to false. So let me show you what I mean. Instead of my birth month is 10, let me put it to be 11. Run. So it did not execute this because my birth month is not 10. It's false. So all this would be false. Then we'd go to the else statement and see what we have. So in contrast, OR requires only one of the statements to be satisfied, but we have 2 statements, so that's okay. So there's at least one. My birthday is 3, and therefore we'd have the following message. One of your birthday or month or year matches. Now if none of them match, let's put 4 here. Oh, still we have a match, which is the year. Let's put 1992, then we'll be here. No match. That's it for composite conditionals. Let's go to ternary operators. We did not talk about strings, so it's a good way to bring it up. So strings, you can define them as follows. String city is Nice. Cout city is equal to city. And else. So here we have to put double quotes, not single quotes. So let's talk about ternary operators. Int postal code is, so I'm going to check the following. Is city equal to Nice? If so, if this is correct, assign the value 6000. Else, assign nothing. Run. Okay, this is executed properly. Let's comment that out, except this one. So cout postal code is Let's print it. Postal code and L. So postal code is 6000. If I add an E, it is 0 because Nice is not Nice. So it will put 0 in postal code. If your statement is true, then you'd put 6000 in postal code. Run and you'd get 6000. Good. So that's it for conditionals. Let's talk about arrays. So arrays are containers. They contain objects or data of same data type, and they have a fixed size. So once I create an array of size 5, the compiler stores or reserves 5 integers in memory for this array. Let's give it a name, call it my array. So my array has 5 integers reserved for its own use. You could store integers inside, let's say 5, 10, -1, 99, and 26. You cannot increase the size of the array, and you cannot decrease the size of the array. This is not allowed. That's the basics of arrays, and let's see how it's implemented on C++. So let's create a new script called arrays.cpp. So the way you declare an array is simply you specify the data type of objects in your array. Let's say I want an array of integers. Then the name of your array, let's say you want to call it my array, followed by brackets where you mention the size of your array, let's say 5, and then parentheses where you want to initialize your array if you want. So if you do not want to initialize your array, that's okay. So running that will not give any error, as you can see, and if you want to initialize it, that's perfectly okay. So that's similar to initializing a simple integer. Let's say int x equal 1. So you just initialize your integer upon declaration. You can do the same thing with arrays, where you assign the value of your 5 integers or less, but not more. So let me show you what I mean. So 13, 0, -1, 99, 26. So now this is your array. It contains the following integers. Let's say you want to access your array. So my first element is, so you want to access the first element. It's not 1, it's 0. So you start counting from 0. So you start counting 0, 1, 2, 3, 4. This is how you index your array. Let me copy paste this here. So I'd like to print all 5 elements. I want to change the indices. So as you can see, I'm counting from 0 till 4, not from 1 till 5. Running that, and there you have it. 13, 0, -1, 99, 26. So what you cannot do, or it doesn't make sense to do, is access the 6th element, which does not exist. My 6th element is this random number right here. Anyway, you get gibberish. And if you access a negative index, you get something meaningless. So let's say you'd like to access -1. So my -1 element is 0. -2 is also 0, or -12. You get a very large number. Anyway, all I mean to say is that if you access meaningless elements, you're not going to do anything. You're not increasing the size of your array, in case you're thinking about that. So let me remove this. Let's say at some point of your code, you'd like to change an element of your array. Let's say I want to change -1 and I want to add to it, let's say 9. Or I'd simply want to change it to, let's say 10. Let's do the printing again. Right here, I'm just printing the elements again after changing the second or the third element, which is -1. This is the first printing, 0, it's here. 13, 0, -1, 99, 26. And the second printing, 13, 0, 10 this time because I changed it right here, 99, 26. Good. You could also go ahead and declare arrays as follows. So if I do not specify the size, that's okay, given that I initialize my array. So if I initialize it to, let's say, 3 integers, that means C++ understands implicitly that the size of this array is 3 because it contains 3 elements. So by logical reasoning, this container is of size 3. We could also access my other array 0, then my other array 1, then a comma, 2, right? And L. Run. There you have it, 10, 20, 30. If I do this, that's an error. You cannot initialize an array which does not have any size. So this will give you an error, as you can see here. You could also initialize 2-dimensional arrays. Let's say char my name, size 5 by 5, an array of an array. 2-dimensional arrays are arrays of arrays. And when I say array of array means each element is an array, right? So here, since I inserted parentheses, means the first index is an array. A, H, M, A, D, then B, A, Z, Z, I, right? So run, everything is okay. Let's say I want to access A. How do I do that? my name. So this is at index 0, so I first put 0. Then A is at also index 0 within this array, right? So 0 and L. And there you have A. So let's print my first name, which is Ahmad. So I need 5 printings. 1, 2, 3, 4, 5. So remember, I'm accessing my first name is within the first element of the array of arrays, which is my name. Right? So I'd always want to point at the first element, which is indexed by 0, as in the first element. Then I'd want to point within the sub-array onto different elements. So 0, 1, 2, 3, and 4. And there you have it. You could do the same thing with the family name, but instead of pointing at the first element, you'd point at the second element, which is my last name. So all I have to do is change the first index to 1. So now this is my first name and this is my last name. So there you have it. This is my first name and this is my last name. Let me just insert some dashes here to separate. In case you want to print them all on the same line, all you have to do is do this. My name 0, 0. Then I'll copy this. Then 2, 3, 4. This is my first name. Then I put a space. Then I start copying my last name. So 1, 0, 1, 1, 2, 3, and a 4. And L, run, and there you have it. That's my name. Let me remove all this so that you could see that this line of code prints this. So this is the first character, A, H, 0, 1. So this is 0, and this is 1. This is 0, and this is 2, 3, and a 4. And same here, but instead of pointing at element 0, we're pointing at element 1. Then we count 0, 1, 2, 3, 4. You could also change elements within two-dimensional arrays as follows. So let's say I would like to change this A to an E, right? So all I have to do is my name. Since I'm pointing here, then I'll start with the first element, which is 0. Then I want to change my A to an E, so I have to point at this element, which is 0, 1, 2, 3. Then I put an E instead of an A, right? And let me do the printing again, run, and there you have it. It's no longer Ahmed, it's Ahmed. Let's talk about looping. So create a script loops.cpp. Perfect. So when do you want to use loops? It's when you're doing a certain task or a certain operation multiple times. So let's start by the simplest loop, which is the while loop. While loops operate as follows. Let's say I have a certain condition while some sort of boolean right here. While, let me put while false to show you what I mean. See out, I will never be here. So if we run this, we won't get anything, because this is read as follows. When this condition is true, keep repeating this. But when it's false, get out. When the compiler is at line 7 and it sees while false, it will never enter this. So it will skip this block of code right here. So let me do something so that this executes sometimes. Let me initialize some sort of flag is equal to, let's initialize it to true. Insert here flag. This is what you will never want to do. Here you'll get stuck in an infinite loop. Let me show you what I mean. If I run this, I will never ever reach line 12 or line 15 because I will always be in this infinite loop. While true, keep executing this. So run, you will see that you will read I will never be here. Let me stop executing this for a while, okay? I will always be here. So run, I will always be here. You'll see that it will never stop printing this message. So let me stop this program. Let's do something to stop it, right? Let me do an int a is equal to 0. While a is less than 5, print this. Then a is equal to a plus 1. So at each time I enter this block of code, a is incremented by 1, and therefore it will at some point reach 5 and it will stop executing this block of code. So let me show you what I mean. A is equal to a and L, run. So as you can see, when a is 0, it is less than 5. This is true. So we go down here. A is 0. Then a is incremented by 1. Then we're back at line 9. 1 is less than 5. It is true. Then we go back in this block of code. A is equal to 1. Then it is incremented again until it reaches 5. So when it's at 4, 4 is strictly less than 5. That's correct. We print 4, then now increment it up to 5. We go back to line 9. Is 5 strictly less than 5? No, it's not. So we exit this block of code. Then we return 0 and the program is done. Now if you want to have less than or equal all you have to do is do this, run, and you can see that 5 is printed. That's all you have to know for while loops. Let's talk about do while loops. So this block of code was dedicated for while loops. So do while is really very similar to while loops, instead that it evaluates the condition after it executes the code. So let me show you what I mean. Int a is 5, do the following while this is true. So a less than 5 and print a. So let's run, and there you have it. So a equal 5 does not satisfy this condition, right? Because 5 is not strictly less than 5, but this block of code is executed, once. So regardless of this condition, the block of code is guaranteed to execute at least once, right? So let me show you what I mean. We had a equal to 5, but 5 is not strictly less than 5, so this statement is false. Regardless, we had this block of code being executed. Let me add an a++, and it doesn't affect because this is false regardless. This is a do while loop. Now let's talk about for loops. So you'd want to use for loops when you're counting something, right? When you're counting in a certain range. So for, let's say I have an int I, which is my counter, it will serve as my counter. Start from 0 while you're less than 5, increment. Okay, so let's print I is equal to I, run, and there you have it. You will print from 0 till 4 because 4 is strictly less than 5, so it will end at 4, and each time I is incremented by 1. So this is read as follows: start with I equal to 0 while this is true, execute this block of code. And at each time you execute this, you have to increment I by 1. So you could do the reverse, by the way. For I is equal to 5, I greater than 0, then decrement I. So you'd start at 5 while I is positive, decrement I. You'd see that you're counting from 5 till 1. If you want 0, you have to include it here. So less than or equal, and there you have it. When is this useful? You could loop over arrays as follows. So let me copy paste the array I had from the previous lecture right here. So I have this 2-dimensional array of characters, and let's say I'm interested in printing, right? I want to print the elements of this array. So I need 2 counters, one for the first name and the other for the last name. So for I is equal to 0, I less than 1 or 2, I++, because I want 0 and 1 for the first index. This is 0 and this is 1, right? Open parenthesis. Then another for loop, counting from j is equal to 0, j less than 5, because we have 5 characters in each subarray, j++, then cout my name I, j. So I did not declare j, let me declare it right here, run. So here's my name. Let's say you want to space between your first name and last name. Well, once you're done with the first loop for I is equal to 0, you can execute a cout with a space, and there you have it. So that's basically it about loops. Let's talk about user input. Let's say you're in a situation where you want to read some input from the user. How do you do so? Well, first of all, you have to declare a string. Call it whatever you want to call it. I'll call it read from user. Okay, so a string is basically a concatenation of characters. You could define a string as follows. Let's call it, this is a text. And something really important here is that we have to insert double quotations instead of a single quotation. So when it's a char, you use a single quotation. Char A is equal to, I don't know, C. But when it's a string, you use double quotations. So this is a string, you can write it as follows. You could print your string out, and there you have it. Okay, so this is a string. It's a concatenation of characters, as you can see. So now let's read some data from a user. So this is the data I need, read from user. And the way you do that is you call the getLine method with cin as first argument and read from user as second argument. Once the compiler is at line 6, it's waiting an input from you, from the user. So let's see that. So as you can see here, the execution is not done. It's still stuck at line 6, waiting for you to enter something. Let me enter I don't know, SOS. Enter. At this point, at line 7, read from user is a string that has the value SOS. Even though you enter an integer, it's a string. It's not an integer. You have to convert the string to an integer as follows. Int read from user as int. You have to take read from user and string to integer. So this is a string and now this is an integer. Oh, as int. Sorry. So let's read some integers now and let's play a game. Let's greet the user with a message saying, let's play. Enter an integer between 1 and 10. So the user has to enter an integer between 1 and 10. Do while read from user as int not equal to 5, stay in the loop. So try a number. Now we have to get it from the user. Get line cin. Let me just copy paste the code up there. So I'll paste it here. Once we're here, the user has guessed that the number is 5. So you guessed it. What's going to happen here is that the user is greeted with the following message. We defined a string and an integer. Then we're going to repeat this block of code as long as read from user as int is not 5. So cout, try a number. Then we're reading that number from the user. We're converting it to an integer. This is the string read from the user. This is the integer conversion, and then we compare it to 5. If it's not 5, do it again. If it is 5, go to line 16 and print you guessed it. So let's give it a shot. Make user input, and there you go. Let's play, enter an integer between 1 and 10, try a number, let's hit 3, 3 again, 2, 1, 0, -1, 5, you guessed it, and the execution is done. So that's it. That's all you need to know about user input. Always read as a string, and you convert it to whatever you want. You could also convert to floats, to doubles, to your own need. Let's take a deeper look on strings. String is nothing other than an array of characters with some fancy functions that we're going to talk about right now that C++ has its own library dedicated for it. Like you could compute the length of a string, you could check if it's empty, you can append or concatenate two strings, and so on. So that being said, let's initialize a string called read from user. Again, we're going to read from user and get line. So we're reading this from a user. Let's say I want to read pi. So pi, and here goes pi. I want to print it. So pi right here, and let me say pi is equal to, let's run this. Okay, so it's stuck on line 6. So that we read pi, say 3.14, and pi is 3.14 because it's a string. 3 is the first character, point or dot is the second character, 1 is the third character, and 4 is the fourth character. So what happens if I want to, play around with pi, add values to it, perform computations with it, and so on? So according to what we learned, you can go ahead and say int pi is equal to stoi pi, right? So string to integer. Let's print that. So 3.14 is printed as 3. The main reason of that is due to the fact that pi, lowercase pi, is an integer. So to solve that, let's declare it as a double and use stod, right? So string to double. And that would solve the issue. Running it, so 3.14 is printed as 3.14. That's it for converting to double. String text is equal to, this is some text. Cout, let's compute the length of this text. So length of variable text is text.length. So length of variable text is 17. So if you count all this, you'd end up with 17. And you should also count the white spaces. So white space is also a character. Now let's check if it's empty. Is text empty? Let's answer this question by calling empty. Now this should return a 0 or 1. 0, it's not empty. Now let's put it as empty. Run. It is empty. And the length is 0. You could also append to strings. So string, another text is, which does not mean anything, right? So how do you append the first and the second text? Simply as follows. Cout text plus another text. So run, and there you have it. This is some text which does not mean anything. So you could also store it in another string as full text is equal to text plus another text, and print full text instead, and you would get the same thing. Another way of appending to a string is using, like if you want to append, instead of saying, let's say you wanted text to be full text, so text as follows is text plus another text. Run, there you have it. And there's another function of doing so, which is, I think it's text.append another text. And there you have it. So append is the same as plus. You're appending to the end of the string. So you're appending another text to the end of the string text. Okay? You could also do this, which means a lot. You can add the text right here, as you can see. Now let's talk about comparing two strings. What does comparing two strings mean? So string text1 is apple, string text2 is banana. So cout text1 dot compare with text2 and L. So here we're comparing text1 versus text2. Let's try to compare text2 versus text1. It's going to be the total opposite. And let's compare something that does not make sense just to show you how this compare function works. So run -1, 1, and 0. So the compare function takes on three values, -1, 1, or 0. So 0 when both texts are the same. If text1 is larger than, the comparison happens as follows. You grab the first two characters, A and B. A from apple, B from banana. If B is greater than A, greater as in it comes after within the alphabet. So B is greater than A in terms of the order in alphabets. C is greater than B, C is greater than A is less than C, and so on. So if text2 is greater than text1 in that sense, then the output is -1. If, on the other hand, text1 is larger than text2, then the output is 1. So you can see that from the second line right here, which is line 18. Text2 is larger than text1, hence an output of 1, right? Let's say you're comparing the same strings, okay? You get a 0, 0, 0. Let's say you have a capital B here. Is it still 0, 0, 0? Well, no, it's not. It's not only that the output is 1 and -1, no. The output is how much difference is there between the different characters. So D is larger than B by 2, right? B is less than D by 2, as line 18 indicates. So let's compare something really nice. Let's say anana. They're both the same, right? And let's add something here, like at the end, E and J. What is the difference between E and J? So if we do the math, E, F, G, H, I, J. So there's 5. So we should see 5, as you can see here. So that's really nice, really fancy. Okay, let's search for some strings within strings. Again, let's say I have a text string. I am Malcolm X. I live in peace, and it's raining somewhere in Beirut. So both have nothing related, but I just thought of those at the moment because Malcolm X means a lot to me and Beirut means a lot to me. Anyways, so yeah, let's search for some strings. Let's say I would like to know if my string has the word peace in it. Right, so peace is at index equal to text dot find. The first index is the word you're looking for, peace. The second index is where you want to start searching. I want to start searching from the beginning of the string. So the second argument is 0. Run, and there you have it, 25. So if you start counting from here till peace, you're going to count 25 characters before reaching peace. So 25 if you start counting from 0. Let's say your word is not there. Do we have a sunny here? No, we don't. Run. We get all this nonsense. Okay, so you can do a simple trick here. Since the index is really large, so if it's greater than text.length, then if that evaluates to true, then it should be a false, right? Because the index for the string we're looking for is greater than the length of the text, means we've exceeded the length of the text. This means that we have not found the string we're looking for, and hence, if this evaluates to true, then we have not found the string. So let me change this here to did we find sunny? Run, false. Did we find peace? True, because this is less than this. Did we find Beirut? Yes. Did we find lowercase Beirut? No, we did not. So that's basically how you look for strings. You could also treat the string, as we said, like an array. You could access the first element, the second element, one third element, I space A. So I space A, right? You could also loop over int I equals 0, I less than text dot length, and cout text I, run, there you have it. So this is equivalent to just really printing text as follows. Okay. You could also insert substrings within strings as follows. Let's say you have text and you would like to insert at index, say I am Malcolm X, I live in peace. So I would like to insert something here between this sentence and this sentence. So where does point come? Let's first look for a point. Let's make use of what we learned. Int index of first period. so the index of this guy right here, right, is equal to text.find dot 0. So I'm looking for a dot, a period. Let me print it to make sure that I have hit right location. Run. So it is at position 30, right? So since this is at position 30, then let's insert something at position 30. So text.insert at this position, which is 30, something like it's sunny in Paris. And let me print text again. There you have it. I am Malcolm X, comma, I live in peace. It's sunny in Paris. And let's insert a dot here and a space. So as you can see, it was placed right before the dot, right? So inserts this piece of text or string before the index of the dot. So let's add 1, right? And give some space here. Run, and there you have it. I am Malcolm X, I live in peace. This is the string we added. It's sunny in Paris, and then it's raining somewhere in Beirut. So that's it for insert. Let's say you would like to erase some stuff, like you would like to erase this one. It's sunny in Paris. You would like to retrieve text again. The way you can do so is text.erase. Starting from the first argument is the index starting from, and the next argument is how many characters you would like to erase. Let's say you'd like to erase 5. So this one would erase 0, 1, 2, 3, 4. Starting from this white space, it would erase this piece of text. So let's print it, text, run, and there you have it. This piece of text was erased. I am starting from 4, 0, 1, 2, 3, 4. Starting from the white space right here, erase 5 characters, which is the white space, which is 1, M is 2, A is 3, L is 4, C is 5. So you would have I, M, O, M, then the rest. So that being said, let's try to erase It's Sunny in Paris using what we have right here. So index of first period is where we would like to start erasing, and we'd like to erase this, the length of this. I mean, this is how much we'd like to erase. So let's define a string called text to erase so that we compute the length of this instead of counting. Text to erase dot length. Right? Run, and there you have it. I am Malcolm X, I live in peace, it's raining somewhere in Beirut. Okay, let's say you'd like to replace some piece of text. So I'd want to remove Beirut and put Nice. So first, let me look for Beirut, and index of Beirut is text dot, as we learned, find Beirut starting from 0. So the index of Beirut is equal to index of Beirut. It's at 58, so now we can call the function replace starting from index of Beirut. And how many characters would I like to replace? 6 characters, 1, 2, 3, 4, 5, 6. I'd like to replace 6 characters with Nice. Then cout text. Let's see how it looks like. It should have Nice instead of Beirut. Run, and there you go. Perfect. Let's talk about vectors. So the only real difference between vectors and arrays is that their size can change. The way you define a vector is using vect, the type of data within the vector, and the name of the vector. I've got an error, and that is because I did not include the library vector as so. So running that, everything is good. So this is my vector, and the way you could add to a vector is as follows. My vector dot push underscore back. Let's say you'd like to push back 300. Then you'd like to push back 200, then 100. Right? So let's see the content of the vector, which you could also treat it as an array like this. That's so cool. Let's do this. 1 and 2. Run. 300, 200, 100. So push back would insert an element at the end of your vector. You can print those as so. For int I is equal to 0, I is less than my vector dot length. I think it's size, right? So I don't think it's a length. We'll make sure right now. So my vector I and L run. So yeah, I was right. It's the size. So it's not like a string. The string uses length. Vectors use size. And there you have it. You could also index your vector elements as so. Dot at I, right? Run. And you'd get the same thing. So dot at I or brackets I is equivalent in terms of vector. Okay, so let's say you would like to remove an element. So my vector, pop back, and cout, let me print my vector again. So the same block of code right here, right? So here we're printing the elements of the vector before popping back, and then we do the same thing. Run, so 300, 200, 100, corresponds to this one. Let me insert some dashes, and then you get 300, 200. So popback is simply removing the last element. So as you can see, we did not specify the size of the vector. We just keep adding, and then we could also remove using the popback method of vectors. Okay, let's say you do not want to remove the last element. You'd like to remove an element at certain indices. The way you can do so is as follows. So let's create another vector of ints, call it my vector, and let's create a big vector. So for int I is equal to 0, I is less than 20, I plus plus, my vector dot push back I times 10, and then let's print it to make sure how our vector looks like. Run, and there you have it. Perfect. So we're appending the index times 10 basically, right? So let's say I do not want those right here. So how do I do that? It's easy. All you have to do is call your vector dot erase. So the way you could point at the beginning is using my vector dot begin. This is the beginning of your vector. In case you want to delete the second one, you should say +1, third one +2, 10th one +9, up till, and this is exclusive, so it's not going to contain the second argument. It's up till the second argument -1. So we said we want to delete 10 up to 13. If the second one is +1, then the 10th one is +9. Then I'd want to say here +13. Print the array again. So let me put some useful messages before erasing. 100, 110, 120, and 130. Right here is after erasing. Run. So this is the part before erasing, right here. And this is the part after erasing, and guess what? We've just removed 90 up to 120, not 100 till 130. So all you have to do is add 10, add 14, run, and there you have it. So 10 is the index. It's really easy. Let's say you want to erase index 10 starting from 10 up till 14 exclusively. So it's still 13, index 13. So there you have it. This is how you erase elements. Okay, so what are functions? Let's create a script called functions. Functions are just block of codes, and they're called with possibly some inputs and possibly some outputs. So let me show you what I mean. Let's say you would like a function that returns an integer that adds, let's say, 2 numbers. So int add number, int a and int b. So this int means that the function is expected to return an integer. So return a plus b. Let's print the result of add number 3, 4, run, it's 7. So we just called this function by passing the arguments 3 to A and 4 to B. It returns 3 plus 4, which is 7. So let's say we wrote this. What does that indicate? Run. It means that if we do not pass the first argument, the second one is by default 0, right? So we can go ahead and do int c as well is equal to 0 and return a plus b plus c and do 1, 2, 3 and the result is 6. If we did this, then it's 1 plus 2 plus 0 because c is not passed, so the result is 3. If I did this, means I didn't pass it any argument, I'm going to get an error because I did not initialize a. So you have to do this so that it returns a 0 because it's no argument. So a and b and c are all zeros. 0 plus 0 plus 0 is a 0. So int returns an int. Let's say I want a function that doesn't return anything. It's a void. Void means nada, nothing. So void print greeting message. And let's take some options, int option, and switch. So switch on option. If option is, I don't know, 0, then print hello sir and L. If option is 1, then print hey madam. If option is 2, bonjour. If option is 3, and so on. You get the point. 3, it's hola. You get it. And by default, we're going to print bye bye. So what this function has to do is it takes an option, which is an integer. If option is 0, following is printed. If option is 1, the following is printed, and so on. If the option is neither 0 till 3, then bye is printed. Let's give it a shot. Print greeting message. So let's say option 1, run, hey madam. Option 2, run, bonjour, right here. Option 3, hola. Option 0, hello sir. And option, I don't know what, bye. Simple as that. If you don't want to have inputs, you can just do this. Void print a message. No inputs. Cout. This is a function with no inputs. Why? So, and I'll remove this. Print a message. I'm calling this function. Run, and there you have it. Okay, that's basically it. Recursive functions. So what is a recursive function? By its name, recursive means recursions. We're doing recursions. So a function that calls itself until it's done. So I'm going to show you an example of a function that is written in a traditional way or an iterative way, and another function which is written in a recursive way. So the function is going to be called getFactorial. The first function is traditional. So calculate the factorial of n. It should return an integer, and int output should return the output. Let's initialize output to 1. For int I is n. I greater than 0. So at each iteration, what you're doing here is that you're multiplying output with the current counter. So let's start. If output is 1, then first time we're multiplying by n. So after a first iteration of this loop, output is n. At n minus 1, output is n times n minus 1, all the way down to 1. So the output after finishing this is n times n minus 1 times n minus 2, all the way down to 2 times 1, which is the factorial, right? Let's give it a shot. Cout get factorial using the traditional way of 4. So the output should be 4 times 3 times 2 times 1, which is 24, right? Now let's do this in a recursive way. Get factorial recursive. So recursive is a function that calls itself. Imagine a function which is calling itself within its own block of code. So let's do some edge cases. If n is 1, then return 1, right? Else, if it's not 1, we'd want to return n times get factorial recursive n minus 1. So what's going on here? Let's say I entered 4. Is 4 1? No, it's not. I'm not going to return 1. Therefore, I will not exit the code. If I return 1, I'm exiting the code. If not, I'm going to return this thing right here. It's 4 times get factorial of 3. 4 minus 1 is 3. So again, is 3 1? No, it's not. Return 3 times get factorial of 2. So as you can see, we're returning 4 times 3 times 2 times. We hit 1, which is the edge case. Therefore, we're returning an integer, and therefore, we're done. So we go back to the initial call of the function, which is when it was 4, and therefore, the output will be 4 times 3 times 2 times 1. And that's called get factorial recursive. Run, and there you have it. The only difference is how the function was implemented. The traditional way is only running a for loop, and that's basically it. So let me show you another function that could be implemented using recursive functions. Let's compute the Fibonacci number. So a Fibonacci number is a number. First two numbers are 1. Any other number is the sum of the previous two numbers. So 3 is 2 plus 1. 13 is 5 plus 8. 5 is 2 plus 3. So index 0 of Fibonacci, if n is 0, return 1, right? If n is 1, also return 1. Else you'd want to return Fibonacci n minus 1 plus Fibonacci n minus 2. So let's give it a shot. Cout. Let's say I would like the number 5, which is at position 0, 1, 2, 3, 4. Fibonacci 4. Run. And there you have it. What comes after 5 is 8. Let's do something more fun. Let's print a bunch of numbers. Let's print the first 10 Fibonacci numbers spaced by a comma. Run. So 1, 1. 2 is 1 plus 1. 3 is 2 plus 1. 21 is 13 plus 8. This comma here is annoying me, so let me do a trick for that. If I is not equal to 9, do that. If I is 9, let me put an else here. Print only that without the comma. So run, there we go. Congrats! Now you know how to implement recursive functions. So it's basically a function that calls itself within its own scope. So let's talk about files. New file, FileIO.cpp. IO stream, and you'd need here the F stream, which is file stream. So there's no doubt that files are really used for writing some stuff programmatically or saving a certain database or whatsoever. So now let's talk about how we create a file. First, let's say you would like to write the following text in your file, string text. This is line number 1. Let's specify the name of the file using of stream writer, then specify the name of your file. I don't know, maybe you want to name it my first file.txt, right? Now you have to handle some error conditions. Maybe for some reason your file could not be opened or something like that. So if you cannot open your file, if not writer, display the following message: I cannot open this file, or I cannot create. It doesn't exist, right? I cannot create this file. And then exit the program because there's nothing else you can do. This is not necessary, but for later use, you could see that the output here, you could always see that code equals 0. So returning -1 is something optional. It indicates that I have entered this block of code, which means that I could not write in my file. So I could also remove it. It doesn't necessarily have to be there. Else, if I could write on my file, if I could create this file, then let's write the string text to my file. So using writer, like you would use cout, writer, text, as so, and end L. Then you'd have to close your file. Writer.close, as so. So after running this script, I should be able to see in the path, I have all my scripts, go to terminal. So to check the path you are in, you only have to type in terminal pwd, and I'm currently in this path. So users, my name, desktop, and so forth. I'm currently in this path. So the file should be created in this path right here. Okay, let's give it a shot. And first of all, let's make sure we don't have the file already created. It won't throw an error if the file is already created. It will overwrite on it. So it would delete and then create the file from scratch if it already exists, but it doesn't. We don't have a file with the name myfirstfile.txt. Let's run code 0, which means that we didn't enter here. Also, we did not see this message, which means that we're in this block. Hence, the file is created and it's right here. Let me open it, and there you have it. Okay, and as you can see, we have 2 lines because end L right here creates a new line for further writing. So if you want to write again, you would write on line 2. Now if I didn't insert end L, let me run it again. As you can see here, there's no line 2. We're still on line 1. So if you want to write again, you would write next to this. This is line number 1. You would write over here, right? So let's say you want to write multiple lines. You could do so using a for loop. Let's say you want to write 10 lines. As so. Now with this, we're going to write the same exact line 10 times, right? So let's say you want to write different lines. Let's say this is line number 1, this is line number 2. So delete this right here and do some string concatenation, plus we have an integer and we would like to convert it to a string. So the way you can do that is using to_string function and pass I. So this is a string. The value I is converted to a string, then concatenated on top of text. So run, and there you have it. Let's say you'd like to start from 1, not 0. All you have to do is I plus 1, right? And there you have it. Let's say you'd like to do this 100 times. And there you have it. This is the text file. So really, this is everything you need to know about writing onto a file. Let me set it back to 10, run, there you have it. So now let's say your purpose is not to create a file, but to append a file. So you would like to write over the file, not overwrite the file. Overwriting the file is this. Overwriting the file would discard everything written on the file and write again. So as you can see, if I run the script, it's overwriting the file. Now let's say I would like to start writing from line 11, right? So how do I do that? Well, it's simple. All you have to do is, instead of typing of stream writer, so you have to have a file that is already created. If it's not already created, this append mode, so iOS 2 colons then app means append. App for append. If this file doesn't exist, then writer would create it for us. And then you could go along and do what we were doing. If not writer, then cout I could not create /append onto this file, else I could. So writer text. Let's say I'd like to add some other text. So string text is I'm currently appending onto line, and let's specify it inside the loop. For int I is 0, I less than, let's say I want to write 10 other lines. I'd like 11 here because we have 10, so I want 11. So how do I do that? Start the loop from 11, then end at 20 plus 2 underscore string I. Okay, so let's run, and there you have it. So we just appended. Now if I run it again, you would see this block written twice because the program would append on top of the existing file. So run again, and there you have it. Let's say the file does not exist. I'm going to delete it. So the file doesn't exist. Run. It would create it for me and just write what it has to write. I forgot to close the file when I'm done. So writer.close as so. Now as you can see, we didn't have an error, but for future use, it's recommended to close the file whenever you're done processing it or appending to it or writing to it. Okay, so run to make sure. Yep, all is good. Okay, that's it for writing, and that's it for appending. Well, how do I read from my file? Actually, let me write again to the file. It's going to create again the file. Okay, comment, then let's start from scratch. How do I read from the file? So we talked about writing or overwriting. We talked about appending to a file. Well, how do I read from a file? Let's say you have a file and you would like to extract each character from this file. Well, you can do so using if stream. Then type in reader and the name of your file, so which is my first file.txt. As we did, you have to check if there's no error opening the file. So if not reader, cout could not open this file. And then if you want, you could return a -1 or not so that you exit the program. Else you could open the file. So let's start reading character by character. So while reader.eof means end of file. So while this is false, and end of file is a function. So while not end of file, do some stuff. So we can get the character simply by reader.get, and the character, let's say the character is a letter. We haven't defined the character, so char letter. Then type the letter on the console. So I don't want an end L because I want the letters to be written as is, right? So I don't want to skip a line every time I read a letter. Last but not least, let's close the file when it's done. Run, and there you have it, really clean. Now why do I have 2 spaces here? That's odd. Because I have a space here and there's another space automatically. Okay, let me remove this space right here, save the file, then run again. Oh, 100. Where did the 100 come from? That's odd. I think there's something. Do while this run. Oh, same error. We have this is line 100. So run. This is line 10. So I shouldn't be messing with the file. So I should give it a new line. Run again. There you have it. So the problem was that I was erasing a \n. So \n, you do not see a \n. But what \n is that you write onto a new line. There's an automatic character that you do not see which indicates end of file. So that's the problem here. Let me remove this line to show you what I mean. And there you could see 99, so it's written twice. To avoid this, we have to have a new line, run, and there you have it. Let me delete the file. How about reading from a file that doesn't exist? What happens? And there you have it. Could not open this file. So reader would not be able to open because this file does not exist, and hence the following message is printed out.